Alrighty, we're finally here, page 43. So just quickly here, just by way of a little bit of review here, example number 3 there, we have that guy riding his bike up the hill and come down, and we're supposed to find the total vertical displacement. This is the graph here, right? And remember, this is a velocity time graph, so at the bottom of the hill, the guy on the bike is going 20 meters per second, and as he climbs the hill, his speed does what? Slows down. In fact, at 4 seconds, it's actually 0, right? And then he goes back down the hill and speeds up, and it's another 4 seconds, and then he approaches minus 20 meters per second. And what we did was we worked out the area, because the area of a VT graph, right, is the displacement, and I believe we had plus 40 there and minus 40 there, right? Giving him an overall vertical displacement of, I think that's 0, right? Then what we did was, that's sort of what's happening on page 43. We flipped the page over, and this is where I sort of started to speed up. We calculated the slope of the line, right? And in fact, that would be from 20 to minus 20 is a rise of minus 40 all over 8 seconds, giving me an acceleration of minus 5 meters per second squared. And I think I asked you, is that possible that the acceleration would be the same going up as it is going down? And then I tossed the ball up and down, and we all agreed that, oh yeah, okay, it makes sense, right? He's actually slowing down at minus 5 meters per second squared on the way up the hill, and speeding up at minus 5 meters per second on the way down the hill, right? And this, I think I asked you to complete, right? Yeah. Right there. So let's just, I know you guys did it already, but let's just have a quick look at this, because this is kind of important. Okay? So from a VT graph, what do we read off the VT graph? We read instantaneous velocity. Instantaneous velocity. It is a graph of velocity. From the VT graph, if we're looking at slope, well, that's giving us acceleration. And if we're talking about 2 points, then we're talking about average acceleration. And if we're talking about 1 point, now how can you find slope at 1 point? Tangent line, right? So it's really like 1 point and then 2 more points to get the slope. Then you're talking about, yes, instantaneous acceleration. And if we're talking about area of a VT graph, well, then you're talking about displacement, right? And if you take the area divided by the time, well, then you're talking about average velocity. All right? And so you might remember, recall whether it was yesterday or the day before, I said that flow chart is very similar to this 2-column thing, right? Just sort of in a different fashion. So I don't know if you like this, go ahead and use this. If you like that, go ahead and use that. Okay, they sort of tell you the same thing. Okay, this one's maybe a little more detailed. Alrighty. Now, we didn't get a chance to look at anything. Oh, I guess that wasn't what I was thinking. Okay, so that's really all we have to do, sort of review here. I'm going to give you some time to work. On page 46, there's 1 to 4, okay? And then on page 69, which is the green paper exercises, there's 4 questions there, 14, 18, 19, and 20. And if you want to just go there right now, you'll notice, you want to go to page 69, you'll notice that they all have graphs, okay? And so just so you're not marking up the textbook, because I don't really want this part marked up, what I did was I copied those graphs for you, so you can work on those. So I'll get you those. You can start on page 46. Numbers 1 to 4. And what I think I might do is I'll maybe give you some time to work on those, and then I'll maybe come back and maybe we'll go through some answers with those ones. So start with those on page 46.